Hey, quick question for you. If you had a glass of hot water and a glass of cold water, and you put them both in the freezer, which one do you think would freeze first? Common sense would say the cold water, right? But here's the twist. Back in 1963, a teenager in Tanzania named Erasto Mpemba noticed something totally weird. So, Mpemba was in school, learning how to make ice cream, and as part of the process, they had to add sugar to hot milk, then let it cool down to room temperature before sticking it in the freezer. But their freezer was tiny, so to save space, he just tossed the hot milk in there right away. And here's the crazy part, after about 90 minutes, Mpemba found that his hot milk had frozen into ice cream, while his classmates' milk, which was at room temperature, was still just a thick liquid. Totally confused, Mpemba went to his physics teacher, but the teacher just told him it must have been a mistake. But Mpemba wasn't satisfied with that answer, so he kept thinking about it. Eventually, he asked Dennis Osborne, a visiting physicist, about it. At first, Osborne didn't buy it either. I mean, it makes sense, right? If you take 1 cup of water at 70 degrees Celsius and another at 30 degrees Celsius and put them in the freezer, the cooler water should freeze first. The hot water has to cool down to 30 degrees Celsius before it can freeze. So obviously, the cold water should have a head start. But Osborne, just out of curiosity, decided to test it. And when he did, he was shocked to find that sometimes the hot water actually freezes faster than the cold water. This blew his mind. So, he invited Mpemba to join him at the University of Dar es Salaam in Tanzania, and they started investigating this weird phenomenon. They ended up calling it the Mpemba effect. Now, scientists have spent years trying to explain this. Some suggest that hot water evaporates more quickly, reducing its volume, so it has less to freeze. Others say that cold water has more dissolved gases, which could lower its freezing point. There's even a theory that maybe the freezer plays a part, like the frost inside the freezer might melt when the hot water goes in, making it easier for the water to freeze faster. But here's the thing, these theories all assume that the Mpemba effect is real. The hot water really does freeze faster than the cold water. But not everyone agrees with that. If you were to try this experiment yourself, it's actually really hard to replicate the Mpemba effect. Even Mpemba and Osborne themselves couldn't consistently get the same results. In 2016, 2 scientists from the UK, Henry Borage from Imperial College London and Paul Linden from the University of Cambridge, did their own experiment to test this. Since they couldn't directly watch the water freezing, they decided to measure how long it took for the water to cool down to 0 degrees Celsius. And they found something surprising. The results totally depended on where they put the thermometer in the water. If the thermometer was at the same depth in both glasses, there was no Mpemba effect. But if there was even a tiny difference in depth, just a centimeter, it could make the hot water freeze faster, giving the false impression that the Mpemba effect was happening. What this experiment showed was just how sensitive the Mpemba effect is. Even though they couldn't prove it for sure, they found out that the reason the experiment is so tricky is that water, especially hot water, is in a kind of unstable state while it cools down, and it's constantly changing in ways we don't fully understand. In 2017, researchers at the University of North Carolina did some computer simulations to study this. They found that under the right conditions, the Mpemba effect, or even the opposite, where cold water heats up faster than hot water, could happen. They theorized that hot water molecules have more energy, so they can explore more ways to cool down, including a shortcut that lets them freeze faster than cold water. Then, in 2020, a team of researchers published an experiment in Nature that successfully recreated the Mpemba effect. They used lasers to create a W-shaped potential well in water, where tiny glass beads could move freely. They ran the experiment 1,000 times, tweaking the conditions each time, and under the right conditions, they confirmed that the hot water did freeze faster. Finally, in March this year, a paper published in Physical Review Letters gave a strict mathematical proof of the Mpemba effect. Using something called thermomajorization theory, they proved that under certain conditions, hot water can freeze faster than cold water. So, there you go. It turns out that, under the right conditions, hot water really can freeze faster than cold water. It's a fascinating phenomenon, and it shows just how much we still have to learn about the world of physics. Who would have thought that something as simple as water could be so full of surprises?